Hi guys, welcome to another Minecraft modding tutorial. Today I'm going to teach you how to add your very own custom furnace to the game. Now this tutorial has took me a while to make. I've been fixing loads of bugs with it and I finally got around to making a tutorial. It's probably going to be a long one, so strap yourselves in for a long tutorial today. I even had to print off the code so I wouldn't forget it, which just shows how long this is. So today we're going to be making a furnace. The furnace that I'm going to be making is slightly different to the vanilla furnace in a way in which it has 2 inputs, 2 outputs, and like 2 fuel slots as well. That's the only difference. I mean, you can make it go faster. I'll show you how you can change that when we write the code. So as this is going to be a long tutorial, you can see in the description some links to different timestamps in the video for the different parts if you're going over it again, if say you've had an issue or something. And I'll also leave the timestamps on the screen right now, so you can always just refer to them when you need it. So the first thing I'm going to do is I'm going to make the block class. So that's block double furnace. Double furnace is the name of the block. And in here I'm going to make this extend a block container as all of our blocks that have an inventory do. We're going to use this constructor here, but we're going to set the material inside here. So that's that's the wrong button. Material.rock, and as we do normally, we're going to take in the unlocalized name here. So that's string unlocalized name, and then this dot set unlocalized name. You know the stuff. Unlocalized name, unlocalized name. Brilliant. I'm also going to set the hardness and the resistance. So set hardness. I'm going to set the hardness to 3 and the resistance to 20. So set resistance to 20. And yep. Now this wants us to add another method, which is the one that will create the tile entity. So if you just hover over this, it should say to create a method. Yep, add unimplemented methods. That'll add the create tile entity. There's also another create tile entity method, which uses the block state. So I'm going to use this one to simply create a tile entity, because this one with the meta will actually return the create tile entity method, except for we'll take the world and we'll do get state from meta, and that should work correctly. Then we need to add the tile entity here like so. Now we're gonna actually have a block state. A furnace can be on 4 different sides, so north, east, south, west, and it also has an activated property where it's on or not. So if up the top we create that public static final, I'm going to create the activated first, so that's a property bool, and that's just going to be called activated, and that equals property bool dot create, and I'm just going to call it activated. Did I spell it right? Yes, I did. And activated. And I'm also going to add another one. That's a public static final property direction. And that's going to be called facing. And that equals property direction dot create. And we're actually going to take one that takes in a plane. So it'd be in the values, I believe. And if we just take in, the name would be facing, and the values would be enum facing dot plane dot horizontal, like so. And that'll basically say you can only have it on the horizontal axis, so that's the north, east, south, west bit. Then, as we do normally, we need to create the block state. So we simply call create block state, return a new block state container. So that's a new block state container we're going to take in this and a new iProperty array, which is going to be activated and facing. So the two properties are, oh, I've accidentally pressed controls. That's brilliant. Not like that. Brilliant. And that will actually create a block state, import iProperty, and we need to set the default state up here. So this dot set default state, and it's this dot block state dot get base state dot with property, and then that's activated, which is going to be false, and then dot with property, and then that's facing, and that's enum facing dot north, like so. And now we need to do the get state from meta, get meta from state. So get state from meta and get meta from state, like so. The get state from meta, the way we're going to do it, we're going to save the activated property. So we're going to say the value 0 to 3 represents north, east, south, west when it's not activated, and 4 to 7 is when it is activated, north, east, south, west. So the way I'm going to do this is I'm going to query is the meta greater than or equal to 4. If it is greater than or equal to 4, then we know it is activated. So it's this dot get default state dot with property, and that is activated, and we're going to set that to true, and we're going to do dot with property, and it's going to be facing, and that's going to be enum facing dot get horizontal, and this is just going to be meta minus 4, because the first 4 values represent the one when it is activated. And what we're going to do is we're simply going to do an otherwise, so using the colon, just going to copy and paste this bit here, but we know that it isn't activated, so that will be set to false, and we do not need to take away 4 because the meta will be between 0 and 3. And I'll just Control Shift F to nicen that up. And next we need to get the meta from the state. So this is quite simple. So what we do is you do state dot get value of activated. So are we activated? If we are activated, we do state dot get value, and we're going to get the facing, and we're going to do the get horizontal index, like so, and then that'll simply add 4 because it's the activated variant. Then otherwise we're going to return just state.getValue dot get horizontal index, and that should simply do the get meta from state. Control Shift F to nicen that off a bit. Next thing we've got to do is the get state from placement. So this is like when we place the block, we want to make it place it the right way round. So we just simply got to return this dot get default state. I've put a semicolon there. Get default state dot with property. When we place it, we don't want it to be activated, so activated. We're going to set this to false. And we're going to add dot with property on the end as well, and facing, and then it's just player dot get horizontal. It's called placer. There you go. It's placer dot get horizontal facing dot get opposite. So if we're placing north, the block will face towards us, which is how we want it to place. We're just going to add some methods for when we break the blocks, so we drop the items. We haven't actually implemented a tile entity, but we can create this already. So the break block method is like we have in other break block methods. We simply do TileEntity te equals world, and I'm going to rename that world here. I don't want it with world in. So Shift Alt R, and then rename that to world, and we do continue world dot get tile entity. If I can spell tile entity at the position, which is exactly what we want, and the item handler, which is what has all the items, is the TileEntity get capability, because we know it will have the capability, which is capability item handler dot hello item handler capability, and the facing will simply be null, because it doesn't have we use that for when it's depending on what face it is. It doesn't matter what face it is, it's going to be the same on all faces, because the way it works. Going to import that. Then we simply need to do a for, and we're going to loop through all the slots. So slot less than handler.get slot, and then we're going to increase the slot like so. That'll loop through every slot. We're going to get the item stack, which is in the slot, so that's handler.get stack in slot, and that's just slot, the one that we're looping through. Import item stack while we're here. Import, brilliant. And simply we do inventory helper dot spawn item stack, and that takes in the world. And then it's just pos.getxyz. So pos.getx, pos.getY, and finally pos.getz. And we've already got the stack that we're going to spawn, and that'll basically spawn all the items that are in the tile entity when we break it. We're also going to do a comparator override. So what I'll do is basically say, like, give a comparator output based on how the inventory is. We just need to say that we're going to override it by setting this to true here. We're then going to do get comparator input override like so. So in here we need to get the tile entity. We can get the handler as well, so we do it just like this. There's a method in the utils class that I have that'll be available on GitHub, and it's just utils.calculate redstone for the item handler, and we need to just rename this to world, and like so that will do the comparator. We'll have the onBlock activated. We'll create that method now, but we can't actually use it yet because we'll have to open GUI. So to do open GUI. There's also a method in the description. Now furnaces produce a little particle when it's activated, so if we head over to the folder that you can get in the description, if we just get the random display tick method, I select all, copy and paste it, and I put it below here, and that should automatically do the furnace sound. It will also do the particle. So just got to import all of this. Finally, we need to get the render type. This is because the block has a tile entity, and otherwise you'll think it uses a tile entity special render, which is something that we haven't actually got set up. We don't need it either for this block, so we're just going to say it is a model, and that will basically say that we're going to use a model to render this block. And like so, we're done in the block class. Now, we're just going to head over to mod blocks, just to register the block. If you take a look in here, I've already created a block double furnace up here. We simply need to initialize it down here. Double furnace equals a new block double furnace. And that's going to be double underscore furnace as the unlocalized name. I just want to note that I changed it to public in here. It was protected before. And if you head down to the register block method, we have register block double furnace down here, and we registered the render for the block down here. And that should be everything to do with the block done. Now let's head over to creating the TileEntity. This is probably going to be the longest part out of all of it. In the description, there will be a link to this class. It's the TileEntity sided inventory class, which basically allows us to have a sided inventory using capabilities, which is really super awesome. It took me a while to get this fully working, and it works a treat now. So what I'm simply going to do is, in a TileEntity package, going to add a new class, and it's TileEntity double furnace. And we just need to make this extend decided inventory so we can use all that code. So this will extend the TileEntity, I can't spell it, entity sided inventory, like so. It's also available in the latest version of CJ Core, this exact class. This will make me add a constructor, like so, which has to do a super, which basically says what slots are, like, represent what. In a way, here we go, we have lots of int arrays. The int, each int in each int array represents the ID of the slot in the main handler. Now on the screen you'll see a picture of the GUI, and I've actually labelled up each of the slots. You should see that on the top you have a 1 and then a 0, 0 being the slot which is going to be smelted immediately. The 1 is just the extra slot on the side, slot 2 and 3 on the bottom, which 2 is going to be the one that's getting smelted, and then it's slot 4 and 5 on the right. And these are the slots in the main handler, but with a furnace only certain slots are accessible on certain sides. So on the bottom of a furnace only the output is available using a hopper. So what we do is we create a new int array like so, and we simply give it the indexes of the main handler slots that side will have access to. So on the bottom it's only the output slots. I need a comma after this. On the top it's only the input slots, which is simply 0 and 1. And then on the side it's a new int array, which is only the fuel slots that we have access to, which will be the same for all of the different sides. So I'm just going to copy and paste this for all the other sides, which basically will set up our inventory appropriately. Now I'm also going to add some workers. To make the syncing with the GUI easier, I'm going to use the capability that we created, which is a worker. And we're going to have a burn worker and another worker, which is a cook worker. The burn worker handles the burning of the fuel, and the cook worker handles the cooking of the items, or the smelting, however you interpret that. So what I'm going to do is I'm going to actually initialize these. So this dot burn worker, and this is equal to a new worker. You can also see the worker class in the description. It's on GitHub. The max cooldown, we're going to initialize the max cooldown to 0 because we don't want it to work until we tell it to work. So in here we need to write what we're going to do while we're burning. So while we're burning, we're going to tell the cook worker to try and do work. So we can use a lambda expression, which is this little bit here, with the bracket, open it up like so. I'm also going to initialize the work done lambda expression, just so we can use it in a second, and close that off. That shouldn't give us any errors. Now, while we're burning, we want to, if the cook worker has got an item it can cook, we're going to tell it to cook the item. So that's just going to be if, and we're first going to check whether we are on the server side. So it's not this.world dot is remote. So that will basically check if it is remote, we're on a client side. If it's not remote, we're on the server side. We want to be on the server side. We're going to check if this.cookworker actually has a cooldown, which we haven't initialized yet. It'll set the max work when we're actually going to cook. If this is actually greater than 0, so we can actually cook, then we're going to tell it to cook the item. So this.cookworker, and we're just going to do a do work, which will basically tell it to do the cooking of the item. I'm going to remove the curly braces on this one because we don't actually need it. So over here, once we finish burning, we need to make sure we update the block state so it sets activated to false. You'll see later on that when the burn worker starts doing work, we'll set it to true, so it is activated. Now we need to set it to false. So again, we need to do the is remote check to make sure we are server side. And if we are server side, then we need to do this dot burn worker, and we're just going to set the max cooldown back to 0 to say that we're not burning anymore. We finished burning the item. We shouldn't reset. So we're just going to do this dot burn worker dot and set max cooldown. I'm going to set that to 0 so it will no longer do work. And finally, we need to do is this.world.set block state. We're going to take the second method, which is going to be this.pos. The state that we're going to use is going to be this.world.get block state for the position that we're at. So we're going to get the current state because we know we will have the right property. Then we're just going to do with property, and that's going to be property block double furnace dot activated, like so, and we're going to set the activated value to true. The flags will simply be free, which will tell it to update the client, like so. Now we need to initialize the cook worker. So when we're cooking, so this.cook worker equals a new worker. The max cooldown again is going to be set to 0 because initially we don't want it to work. I'm going to initialize the lambda expressions for these, which is like so. And again, for this one, it's exactly the same. We'll just initialize it like this. So what we're going to do in the cook worker is we're going to say, if we can't smelt anymore, so suddenly the item's been took out or something, we're going to actually make the cook worker reverse itself and start counting down. Now that was actually something I've added to the worker class, that feature, so you can see that on the GitHub change. So we first need to add the can smelt method, which is here. Going to copy and paste this and just close it. And simply on the bottom we're going to add can smelt. This will basically say whether we can currently smelt. I'm just going to work you through this method. So what we're first going to do is slot 0 is a slot which has the item which is going to be smelted. If the result of the smelting is empty, i.e. there's no result, then we can't smelt that item. If the output slot is empty though, we can smelt that item. If that isn't true and it isn't empty, it's got an item in, we're going to check whether it isn't the same as if the items in slot 4 is different to the result. If it is, we'll try and put it in slot 5. So if slot 5 is empty, we'll say we can smelt. If the items aren't equal, though, the two items, we can't smelt it. And then otherwise, we're going to make sure we can actually smelt it so the total of the two items are less than the max stack size and the slot limit for that item. And we also going to do the same for slot 4. If they are the same item, we're going to make sure they add together to be less than 64 pretty much. And that is how that works. So again, we're going to add the is remote check by copy and pasting this when we're burning. If the world isn't remote, so we're server side again, we're going to check if we can't smelt. So if we can't smelt, we're going to actually reverse the cook worker. So we do a .set reversed. I'm going to say it is reversed by setting that to true. Otherwise, we're going to set it to false. So it isn't reversed, continue going as normal. Like so. So that'll basically, if you suddenly put the item back in after it's gone down, it'll only lose a bit of the progress. It won't fully reset. So first of all, we want to make sure we are server side. Again, it's another is remote check. You guessed it. And what we're going to simply do is, when we've finished cooking, we just say we're no longer cooking. So it won't repeat cook by setting the max cooldown back to 0 like we did with the burn one once we finished burning. Then what we're going to do is we're actually going to provide the item to the output slot. So we're going to actually smelt it. So it's item stack. And that's going to be to smelt. This is the item we are going to smelt, and that's this .handler. Now you notice handler is actually the item handler, the main item handler. We don't have access to the other item handlers, and that is intentional. What we can do is we're going to extract an item. You see there is an internal method. That is only used by one method, which you will use later. This will basically bypass like updating all the other handlers for each side, which we don't normally want to do. It's only on certain cases that we do want to do that. So we're simply going to do extract item, and we're going to extract it from slot 0, I believe. That's the slot which contains the item we're going to smelt. We're going to take away 1. This is not a simulation, we're actually going to do it. Then we're going to have an item stack result, and we can just copy and paste this bit here. It's simply the item that we're going to get added. We make sure to copy the item so it doesn't change the actual furnace recipe item, because I have known that before to start duplicating items, and that's something we do not want. Then what we're going to do is we're going to create a new item stack, which is going to be the leftover item stack. So this is if we can't insert it into slot 4, it'll put it in slot 5 basically, and that's this .handler.insert item, and it's going to be inserted into slot 4. The item stack is the result, and that's going to be false, like so. We're then going to do if the leftover isn't empty, so it didn't insert the item fully. We're then going to do, we're then going to try and insert it into the other slot, the 5th slot. So that is the leftover we're going to try and insert, and this is not a simulation again. Brilliant. Obviously, if you aren't doing a double furnace like I am, you will not need this line of code here, because you won't have a leftover, and also this method here, this bit here, would not be needed. If the item isn't equal, you'd simply return false, because you wouldn't be able to insert. Now, that is everything to do with the workers done. We just need to add the update method. Now, this means we need to implement iTickable, which basically says that we're going to have an update method. And I'm going to put this before the can smelt. We're going to call the update, and we're going to add the is remote check again. Make sure we are server side, because typically all TileEntity work will be server side, and we're going to now say if the burn worker has actually got a max cooldown, we're going to make it do the work. So this, if this dot burn worker dot get max cooldown, get max, that's it, get max work. If that's greater than 0, we're going to tell the burn worker to do work, like so. Then what we're going to do is, if we can smelt an item, we're going to say take the fuel away if there is a fuel, and we're also going to actually start cooking that item if we're not already cooking. The reason why we start the burning if we can smelt, there's no point just continually burning fuel even if we can't smelt. That is not how the furnace works. So in here, we're going to add another if statement. We're going to check whether the cooker has finished. So we do that by doing get max work. If that's equal to 0, that's when the cooker is finished or hasn't ever started, like we initialized above. And we're going to ensure that the burn worker is actually working as well by getting the max work and checking it isn't 0. If it is actually burning, then what we're going to do is going to do cook worker, and we're going to set the max cooldown, and this is where we actually say how long it's going to take to cook every item. Now the default value is 200 ticks. If you want to make it super fast, you can set it to 5. I'll let you experiment with that value to basically change the speed of the furnace. And then we need to ensure we reset the set reversed. Make sure it's on the right one by doing set reversed, and setting it to false. It isn't reversed. We're going to start counting up. Now we also are going to do the burning of the fuel. So if this .TileEntity furnace dot is item fuel, so we're going to ensure the item is a fuel, and that is this .handler .get stacking slot, and this is slot number 2. And we're also going to check whether we have actually finished burning. So this .burn worker .get max work is equal to 0. So that will ensure we're not currently burning an item and we can actually burn this item. If so, this is where we're going to set the block state again. So I'm going to copy and paste the line from above and make the activated true. This should have been false earlier. Brilliant. And that will simply update the block state. We then need to set the max cooldown correctly. So this .burn worker .set max cooldown, and the max cooldown will be set to TileEntity furnace get item burn time, and that's going to be this handler get stack in slot number 2, like so. So say it's coal, that's a burn time of 1600, that will get the burn time of 1600 and set it appropriately. And then what we're going to do is this handler extract item, and we're going to extract the item from slot 2. We're going to take 1, and it's not a simulation. And that should be the update method done. Now there's a couple of more stuff that we need to add. The next one is a new method which you can get from the description of the video. This is for shifting the item. This is purely for me. What it'll simply do is, if say you put like coal in the slot on the bottom left, it'll shift it to the bottom right, and you'll see when we're in game. And what we simply need to do is need to override a method called onSlotChanged. This is a method which is called in the sided inventory when we change a slot. If I just head down to the main handler, item stack handler, when we change a slot, it simply calls onSlotChanged, and that's basically when you insert an item, take an item out, stuff like that. We don't need to call it a super because there isn't one. There's nothing above. And simply we need to do if the slot is equal to slot 0 or the slot is equal to slot 1. So it's one of the input slots in the top. We're going to make sure that we shift the slot from slot A to slot B. So that's going to be from 1 to 0. So whatever's on the left, we're going to shift it to the right. We're then going to do something similar for the others. So if the slot is equal to slot 2 or the slot is equal to 3, then we're going to shift the slot, and that's going to be from slot 3 to slot 2. And then finally we can do if the slot is equal to 4, because we don't need to shift from 5, because that'll only be taken out. We're just going to shift the slot from 4 to 5. From 4 to 5. And we might as well do if we change slot 5 as well, like so. That will just shift the slots appropriately. You'll understand when I show it you in the game. Next, we are actually going to add a isStackValid method. This is so that in the item handlers for each side, we're going to say whether the item stack it's trying to insert is valid. And this will simply do if the slot is in slot 2 or slot 3, aka it's a fuel, we're going to say, well, it'll only be valid if it is actually a fuel. So that's TileEntity furnace dot is item fuel, and that's stack. We're going to pass in there, and we're also going to check if it is either a fuel or it's like a lava bucket, because you can put lava buckets in. If it is a lava bucket, and we're going to make sure that it is not, the item is just not a regular bucket. We can't put a regular bucket in. So stack.getItem. If that's not equal to items.bucket, so it's not equal to a regular empty bucket, but it is a lava bucket, we'll accept it. And we're also going to do if slot is equal to slot 4 or slot equal to slot 5. We're going to say no, you can't insert a slot into slot 4 or 5. That's the output slot. That's when you get stuff out. And that will basically say whether our slots are valid. So we also need to add the should refresh method. So this is basically when we change the block state, should we refresh the state? Gonna Shift or R and make sure they spell that correctly, because that is a mapping error. State. And what we're going to simply do is return whether the block is actually physically changed. So if the old state dot get block, so if it's no longer our furnace, we know we should remove the tile entity. If it is still our furnace and we just updated where it's activated, we shouldn't remove the tile entity. And next we need to add the write and read from NBT. So that's write to NBT and read from NBT, like so. And what we're just going to do is nbt.set tag, and we're going to set the burn worker to this.burn worker.serialize NBT. And we're going to do the same for the cook worker, except for we're going to change it to cook worker here and cook worker here, like so. And we're also going to do the read from NBT, so that's just going to be the default super first, and then we're going to do this dot burn worker dot deserialize NBT, and that's just NBT dot get compound tag, and that's just going to be the burn worker tag, like so. We can copy and paste this for the cook worker as well. and that will sort out the saving of these two. We then need to add the capability. So we has capability and get capability method. So has capability, and what we're going to do is if the capability is equal to mod capabilities dot capability worker, we're going to say true. Otherwise we're going to use a super, because that will handle the inventory as well. Then we're just going to do get capability, and we're going to do something a bit different here, because we've got two worker capabilities and this is only going to be accessed using the GUI. We're not going to ignore the side. We're going to actually use the side now, because we've got two. To say when it's facing north, we'll return the burn worker, and when it's south, we'll return the cook worker. That's how we're going to do that. So if capability, and if the capability is the mod capabilities dot capability worker, if it is the worker capability, we're then going to check if facing is equal to enum facing dot north. If we're facing north, then we will return this, cast it to T, this dot burn worker. Otherwise, if the facing is equal to enum facing dot south, this can be any enum facing. Just make sure we use the same one in the GUI. That's an else if, and we're simply just going to return, casting it to T, this dot cook worker, like so. And I believe that is the tile entity finished. Thank goodness for that. Now, we need to create the container. So in a container package, we're going to add a container double furnace, like so. And we're going to we're going to make this extend a container as we would normally. And that's the net.minecraft.inventory container. And here it's going to make us add a constructor, maybe, or is it a method? It'll make us make a method. Is usable by player, I believe it is, or can interactive. And this will simply return player dot get position, if I spell player correctly. So player dot get position dot distance squared, so distance SQ, and then it's going to be TE. Now we need to actually get the tile entity, but for now it's just going to be this.te.get.pos.add, and that's just 0.5, 0.5, 0.5. And we're now just going to check whether that's less than or equal to 64. So that's basically, are we in an 8-block radius? And what we need to do is we need to actually add a constructor. So we're going to add a tile entity double furnace on the top. So private tile entity double furnace. And that's just going to be TE. That will make sure the can interact with method works. And we're going to do a private item handler, which is just the handler. And now in the constructor, we're going to open it up like so. Going to make sure we import the item handler as well, like so. And in a constructor, we're going to take an entity player this time. We normally take the player inventory, but we need the actual player for this one, because when you take an item out of a furnace, it gives you XP, so we need the player to do that. And then we're also going to take in the tile entity double furnace as well. That's T8. I haven't made it like the 1.13 furnace, which stores experience. It's just going to be the default one for the version I am on. So it's just this.te equals te, and then this.handler equals te.getCapability, and that is capability item handler dot item handler capability, and the facing is going to be null, and that should initialize the handler. Now we need to set the slots correctly, like we do always. In the folder as well, you can see the two slots that we're going to use, which is a slot furnace fuel and slot furnace output. I've already got slot furnace fuel, I'll just override that anyway. And if we take a look at the fuel and output class, the slot furnace fuel and slot furnace output, these are custom ones which basically allow us to use capabilities with the slots. There's simply the fuel one checks whether it's a fuel or it's a bucket, and the get stack limit is it a bucket? If so, 1, otherwise just get the super. And then the slot furnace output will simply give the XP appropriately, and I've also set it up to give you the achievement and fire the appropriate event, so that would work. So going back to the container, we now need to add all the slots to the container. So this is to add slot to container, and I've put a semicolon in there. Add slot to container is going to be a new slot item handler. That's for the input slot, so slot 1 and slot 0. And because these can accept any item, it's just going to be the handler, which is this dot handler. The index of the slot, this is going to be slot 0, and I already know the positions of the slot in the inventory, which is going to be 56, 17 for me, and I'm just going to copy and paste this and fill in the other slots. You will notice that I've actually done it a weird way, how it goes 1, 0, but that's just to make the code easier for me to understand. It's nothing other than that. These are actually slot furnace fuel. These two are. So furnace fuel. And we'll have to import this. Like so. Import. And it's going to be the CJMinecraft.bit container.slots. Because that's the one that accepts the inventory handler. Then we need to do this dot add slot to container, and this is going to be a new slot furnace output. So slot furnace output, and it's going to be the one that takes in the player and then the item handler. So the player is the player, the handler is this dot handler, like so. Yep. The index is index 4, and this slot is at 118.35. So this is all the slots that we use for our inventory. Now we need to add the player's inventory. So we can actually just go to the block breaker container and copy and paste the inventory bit, which we have down here. It is actually exactly the same. It's in the same location, which makes our life so much easier. Obviously you can see it on the screen now. If I press Ctrl Shift F, that should fix it up. Where it says player inventory, though, is player dot inventory, because we normally pass in the player inventory. This time we are not doing that, so that's player dot inventory. And here it is player.inventory as well. And Control Shift F should fix that up nicely. I'm just going to sort out that comment because that would annoy me. And that will add all our slots. We then need to add the transfer stack in slot method. So if we head over to the transfer stack in slot method that I've provided, we can now copy and paste this. and just paste it underneath here. The way this works is pretty simple. We'll probably have to import some things like the item stack and the TileEntity furnace for this to work. What it does is if the item is a fuel that we're shifting in, it will make sure to put it in the fuel slot before it puts it in the actual smelting slot. That is just something I've done, a quality of life change. Obviously you don't have to do that, but that's just something I've chose to do. And I'm just going to close these. That should be the container done. Now let's move on to the GUI. So if we head over to client.gui, we can add the GUI class. So that's GUI double furnace. This is going to use CJ Core. Obviously you can do it your own way with the element system that I used before, with the progress bars and that lot. But I enjoy using CJ Core for this. It's not directly a CJ Core. This is how I'm making GUI. So it's a GUI base. This one is, we're going to add a public static final resource location, and that is the, just press Control Space to import that. Hopefully it's texture, and this is equal to a new resource location, which is going to take the reference.modid. And it's also going to take in the texture location, which is textures slash GUI slash container slash double underscore furnace dot png. You'll actually be able to get this in the GUI image in the description. It's going to make us want to add a constructor as well. So we're going to do this one, which takes in the resource location as well. I'm just going to put that underneath here, like so. Reference has not been imported, so I need to import that. Hover over this, like so. I can't spell resource apparently, like so. And what we're going to do is, in the constructor, we are going to take in an entity player and a TileEntity double furnace, and that's just going to be TE. And in the container, it's going to be a new container double furnace. I'm pressing Control Space again to bring up this double furnace, which will take in the player and TileEntity. The texture is simply once it's done that, the texture is simply texture. Need to import the double furnace like so, and import the entity player as well, like so. There's a couple of more variables that we need to add in here. We're going to add a private static int, and that's the sync variable, so we sync appropriately using our packet, which we have set up in the capability or the networking tutorial, one of the two. We're going to set the burn min, we're going to set that equal to 0, and we're also going to set the burn max, and that's equal to 1. And just can copy and paste this for the cook min and the cook max. And these are the variables that we're going to sync with when using our packets. We also need the TileEntity in here, because we're going to use that to actually update mainly for the position really. We are going to have a private TileEntity, Control Space again, double furnace, which is TE, and just going to do this dot TE, and that's equal to TE. We're also going to do this dot name. This is something that's purely for the CJ Core GUI system. We're going to set the name to container.double underscore furnace, because this will automatically draw our GUI, like the text on the top. You can take a look at the code that I use. I don't know why it's added player there, that's weird. And one more thing, we need to set the GUI size, so we can type set GUI size, And the width for the GUI that I'm using is 176 by 166. And we are nearly there. We need to simply init the GUI, which will basically, we're going to add our element. We need to call the super first, and then underneath we need to add element, control space to get that method, and it's going to be a new element progress bar. We can also add a progress bar like we did in a progress bar tutorial. We're going to take this in as the GUI. The position X is 56. Position Y is 36. I also have the width and the height, which is 14 and by 14. And this is for the burning one. And this is dot set direction. So the direction of the burning one, which is progress bar direction dot, and this will be up to down, up to down, and we want the element progress bar, not the progress bar one, because we're using the CJ core version of this. And we also need to set the texture UV. This will actually set the location of the other, the overlay for the texture. So this is at 176, 0 in the image file, and we're going to set the actual texture that we're going to use using set texture, and the texture is the texture above, and it's 256 by 256 wide. That's the width and height, and that will sort out that element. We need to simply copy and paste this for the other one, but change the values a bit. So the other progress bar, which is the arrow, this is at 7934, and this is actually 24 by 18. The direction will be left to right, and the location of the overlay texture is at 176.14, just under the other one. And finally, we need to add a update element information method, and we're going to just call the super before everything else. And if the burn min is equal to 0, so i.e. we finish burning, we don't want to show the burn timer, and that's 2 equals for that. So what I'm going to do is burn min equals burn max. We don't need to do that for the other, for the cooking. Now we need to actually set the burn min and burn max of the element correctly. So casting the element progress bar here, so element progress bar, and that's this dot element dot get, and dot get, and that's 0, I mean the first element, and get, hello, it stopped responding. Get the first element, which is this one up here, which is the burn one. And what we're going to simply do is we're going to do a dot set the min value, and the minimum value of this one is burn min, and we're going to do the set max value, which is burn max. Pretty self-explanatory here, and going to copy and paste this for the other one. So copy and paste, except for it's going to be get the other element, which is element 1, and it's going to be set to cook min and cook max, like so. And now we're going to do sync stuff, so we're going to do sync plus plus, then going to do sync mod equals, and we always sync every 10 ticks, which is every half a second. Then if the sync is equal to 0, just need to send our packets, which is packet handler dot instance. Now we need to make sure we use the bit of everything packet here, packet handler. I can't spell packet apparently, and it's the bit of everything one, not the CJ core one, otherwise we cannot send the messages correctly. And we're going to do send to server, a new packet get worker, control space, it's this one here, like so. The position is this.t.get pos. The side, now if you remember in the TileEntity over here in the capability, the north side was the burn and the south was the cook. So we're going to do the burn worker first, so that's enum facing dot north, that'll be on the north side, the capability on the north side. The class name is just this class name, so if I copy and paste the package bit up here, which like so, copy and paste that, control space to import that, hopefully. Yep, and we need to just add the .gui double furnace, so that is this class. The cooldown field name, which is burn min, and the other one is called burn max, like so. That will send our packet. We need to send another packet as well to get the other worker, which is on the south side, if you remember in the capability, which is the cook worker. So that'll be cook min and cook max. And like that, that is the majority of our code done. We just need to head over to the GUI handler and make sure we open our GUI. So public static final int, we're going to add the ID, which is double underscore furnace. The ID will be equal to 3. We're going to use a switch here, and if the case is double underscore furnace, we're going to return a new container, control space double furnace, and that's going to take in the player. So that's player, and a TileEntity is casting to a TileEntity double furnace in here. So excuse me, TileEntity double furnace, like so, and then that's just world.get TileEntity at the pos. And we're just going to copy and paste this for the GUI. So copy, paste, except for it's a GUI double furnace, and it will take in the same parameters as the other one. Okay, so that's the GUI handler done. We just need to head over to the block, and we need to first do the first to do, which is where we actually create the TileEntity. This will just return a new TileEntity double furnace, and like that. And now down the bottom we need to open the GUI, so that is player dot open, and I need to rename the player. So again, Shift Alt R on the player variable at the top to rename, and like so, just to player. And while we're at it, I'll do the world as well. Continue. Shift Alt R, and like so. I'm just then going to open the GUI, so player.open, Oh. Okay, it didn't like that. Then we're going to open GUI, which is player.openGUI. The mod is bit of everything dot instance. Like so. The GUI ID is GUI handler dot. And hello. And then that's the double furnace. The world is this one here. So Shift Alt R. I'm going to rename this to just world. Like so. So we don't have to change that. And then we just need to enter the XYZ that we're going to open GUI at. So that's pos. Yeah, we have pos. Pos.get x. Pos.get y. And finally pos.get z. Like so. We just need to head over to the common proxy now and register the TileEntity, which shouldn't be too hard. I can just literally copy and paste one of these lines to register the TileEntity. It's TileEntity double furnace, and the ID of this one is double underscore furnace. Like so. That should be everything done. Now if we head over to the resources, you can see that I've already added the textures and stuff, so you can get them in the description. I've got a block state over here. You've got the block state here. We've got the models, the block model and the item model, as well as the textures of the GUI and of the block. Now let's run the game, and fingers crossed everything works. So let's just wait for the game to load up. Okay, so the game is loaded up. We have had no errors so far. Fingers crossed, we've got no errors when we load the game. Now, I'm already had the block in, but the code should be exactly the same. This is because I actually created it, deleted it, and recorded and created it again. Just for you guys. Just so you can get an extra long modding tutorial. So, the game is loaded up. We have the double furnace, and it is working. I'm just going to go into creative. Delete it. You see the items drop exactly how I was expecting. I'm just going to clear my inventory because I've got loads of crap from testing. We're going to get the double furnace and simply whip it down. Get some hoppers as well, because we want to test out how this works. So just place it like that. Get a hopper on top, hopper there, and hopper on the bottom. I'll remove the bottom one for now, and here we go. Oh, I just realised something that we need to do. In the on block activated, down the bottom, I believe it is. We don't want to return super, we want to return true, so it doesn't place a block. I believe. There you go. Save that. I've got it in debug mode, so that does mean it will update once it's finished building the workspace. Which it should do in a second. Hopefully. There we go. There we go. And now when we shift right click, there you go. With right click, there you go, double furnace. Now that shouldn't just be displaying, that's something. Okay, so that is a bug, I believe. Okay, well, I'll have to mess about with that. You will see the update on GitHub when I fix that issue. Ignore that for now. You should be able to see that the inventory works. So if I go grab well, the way I can actually show you the inventory working is using the item multimeter. Now, for some reason, that's a fluid. The names of the items are a bit messed up. I don't understand why. I'll sort that out soon. I'm just going to grab some stuff to smelt, some sand, and also going to grab some coal from the materials tab. And you should be able to see, if we put coal in the bottom left, it automatically shifts for us. If I split it in two, it will automatically shift for us. Now, we can't put sand in because that is a none. So that's what item. And if you look, the item multimeter is seeing the correct block. I'm just going to take out the coal and put the gold in. You see, it doesn't recognise the gold, but on the top it does. Now, that's the power of the sided inventory. That's the sided inventory in action. And if we was to look underneath, once it's smelted one, so if you put one in, we should see that it's smelting. The burn time will go down correctly, and you should see that it's smelt. Puts one gold in, and we look underneath, and we can see it's there, which is brilliant. Now, we can also pipe items in from the side and on the top. So if I grab ourselves a hopper, on the top we can put anything in, and then pipe it into the top, and in here we can put coal in. If we say put gold in, it will not put the gold in, because it can't go in because it's full. If I take that out, it shifts it over correctly, and the gold is still not going in. Even if it's first, it can't go in, which is brilliant. And you can see it's just smelting it. If we get this, you should hear the XP. If I was in survival, so game mode S, you should see that we get XP. I'll quickly go into the TileEntity and change the speed of it. So like I said earlier, that this 200 is the speed. If I say set it to 5, it should go turbo speed. So it's on 5. Once it finishes smelting, it will suddenly go really fast. Hopefully. Yeah, there you go. And you see how it's currently going so fast. I'll take it out. I should get XP. Now, XP is now apparently broken. It worked earlier. That'll be fixed for you guys though. So yeah, I don't quite understand why it's not working. That's got me bamboozled. Because it worked before. And it's the same code. What did I change? Now, you can also see if we place the hopper underneath, the output will go through. So we'll wait for a gold to smelt, and we'll see the output down here. Hopefully. You can also try with some tin. So the gold has gone down there. Try putting tin in. One thing I would like to ask is, you see how I just switched up there? It kept the burn time. One thing though, if you have a hopper underneath, you do not get XP. Is a known thing. I think that's with vanilla ones as well. Do not get XP. But yeah, that's a custom furnace for you guys. And you can see when this goes out, it doesn't seem to me like the burn worker is updating. I mean, it is cooking, but the cook worker isn't showing any change. I didn't save. That's why. I needed to save. And that should work now. Yep, there you go. You can see that it's actually worked. The thing is going down like so. And yeah, that's a custom furnace. Now, a couple of the issues, if you have any issues with this, be sure to let me know and I'll try and fix it, and you'll see the update on GitHub. You can see once it's finished burning, it's done. And that stopped. Now, should it stop? I don't think it should. So, quick fix. If that suddenly stops burning, and we are currently cooking, then we set the cook. Okay. So, if the burn worker, when the burn worker stops, we do this dot cook worker dot set. And we're going to just set the max cooldown to 0. And that should sort that out, I believe. So when it stops burning, let's just get like a stick or something. That's a quick burn. So that'll burn really quickly. That should reset. Which is exactly what it did. We just need to fix that GUI issue, which I will do in my spare time. But for now, thank you guys for watching. Don't forget to like, comment and subscribe. I am out.